Ladies and gentlemen, and first of all, I would like to thank iada for having me here. And I will talk about historic herbaria conservation, focusing mainly on modern analytical methods that you can use to analyze this kind of objects, because they're unusual and very unique. My adventure with historic herbaria began a couple of years ago when, as a paper conservator, I had the impression that not all the methods that I'm used to as a paper conservator may be suitable for herbaria. And it was 2 years later that I had an opportunity to dig a little bit more into this topic, thanks to the Polish Ministry of Culture and Heritage and their promotion, Creativity Promotion Fund. This project enabled me to decide how to use the money, because the scholarship provides the fixed money and you can decide what you want to do. And I decided just to make some analyses, and it enabled me to cooperate with brilliant scientists. And now I treat it as a pilot studies that I want to make use of in my next project concerning herbaria. But let's get back to the topic. This project included conservation treatment and analysis of herbaria of Michal Fedorowski, who was a Polish ethnobotanist living at the turn of 19th and 20th centuries. This herbaria are a part of the collection of Warsaw University Herbarium, and the project included 13 items. And Michal Fedorowski was ethnobotanist, which means that he was doing ethnobotanic queries in the area of today. This area belongs to Belarus, and he was making queries about the usage of wild and cultivated plants. And he developed the results as herbaria. So he collected the plants, he desiccated the specimens, attached them to the paper support. Oh no, it's not working. Okay. And provided handwritten descriptions about each plant, containing common names, scientific names, and descriptions of usage and functions. As you see, the condition was not very fine. The paper was poor, the paper was brittle, yellowed on the edges, and the specimens were not complete. And the researchers didn't want to work on this archival material before the conservation treatment. So although, as I said, as a paper conservator, before I had the doubts that the methods we are used to as paper conservators may not be suitable, I had to invent something, because I couldn't say, oh, let's leave it, because I'm not sure if what I always do in paper conservation is suitable for that. So what we need to consider when we think about herbaria and when we work with the herbaria is that they're a source of scientific information in many different domains, some of which you have listed here, and many of them require DNA sampling from the specimens. So it holds conservators and curators responsible for DNA preservation, which I think you can agree that is not very common in our daily paper conservation practice to think about. And to complicate it a little bit more, there are many factors that can affect the condition and the quality of the material we're working with, starting from the very beginning. That means the specimen collection, the way the specimen was prepared for drying, the way it was dried, mounted, treated against pests, stored, and possibly treated during the conservation treatment. We can analyze some of the features of the herbaria. Most frequently, pesticides are analyzed, and this is very reasonable, because pesticides are harmful not only to the pests, but also to our health. So this is a main focus when we think about herbaria, but also adhesives with which plant specimens were mounted are analyzed. If we intend to exhibit the items, we can do the microfading tests. And about pH, I will talk a little bit later because this is interesting. And of course, we can analyze other elements if we had ones. Like here, this is quite unusual, but we have a paint layer because the specimens were painted to enhance and preserve the color. But as you see, it's the paint that remained in its color, and the specimen has already darkened, and now it's another conservation issue to how to consolidate the paint layer. Because, as you saw, this material is very heterogeneous and it's not reproducible, so we cannot just take out the sample and replace it with the other material. The preferred methods, analytical methods that we can use are the ones that I would call the holistic ones, the ones that give us general, overall information about the object. Of course, when it comes to adhesives, we can use methods that require taking out the sample, but especially for pesticides, the preferred methods are XRF and gas chromatography. The first thing we did was macro XRF. It was performed by Professor Piotr Targowski from the Center of Modern Interdisciplinary Technologies in Toruń. And this method is very nice as for the identification of pesticides, because it scans the whole area and it maps the distribution of different elements. So especially for pesticides which migrate from the plant specimen onto the paper support, it is very suitable, because if we just were doing the shooting like with a portable XRF tracer or something, we could have just the wrong results. So here, fortunately, we didn't find any mercury chloride or arsenic that we were looking for using this method, but we obtained nice maps of distribution of different elements, micro and macro elements in the plant. So this is how it looks like. And it's really good method. Here you can see the distribution of metal elements that you can compare with the photography. The next thing we did was gas chromatography combined with solid phase micro extraction. Gas chromatography is widely used to detect volatile compounds of pesticides. Here you can see the picture from Lea Delwalder work. She used a different method, and it was published in JPC, I think, 2 years ago. We used SPME that uses a needle that is formed by the sorbent fibers, and you put the needle into the inside the object you want to analyze. Then you close the object. The needle absorbs the inner air, and then you inject the needle into the gas chromatograph and get it analyzed. So we put the needle for 1 hour. I think next time we'll need a little bit more time to do it, to make the analysis. But we observed traces of formaldehyde, diisopropyl naphthalene, and thymol. The other test, we didn't intend to exhibit the herbaria, but we had a chance to make the analysis, so we wanted to take the advantage of the funding. And this method is micro-invasive, and it is very nice to compare the light fastness of certain areas in the object, and to compare our predictions of how light fast is the object, how vulnerable to light it is. So it is actually a kind of aging test that is made inside the object. From our result, we found out that Actually, these were not the specimens that were most vulnerable to light, but the inks and the paper, and only marigold, Calendula officinalis, was the one specimen that is comparably vulnerable to light, just as the ink or paper. Apart from that, we did Raman scattering, and we detected gamma arabic that was used to mount the plants. And I was measuring pH, and I found it very interesting because comparing to the methods I described before, it may seem not to be so attractive. But it is interesting because I think that as paper conservators, we sometimes kind of predict the pH value of the paper we are looking at. And here you can say actually anything, and you can say nothing about the pH of the specimens because they showed really various pH levels from about 4 to 8, and this posed a question for me: should we consider the acidification of the paper if the paper is acidic or no? And the other thing is that elevated pH can accelerate DNA degradation, and this kind of interrelation between conservation treatment and possible impact of this conservation treatment and DNA material and quality of genetic material is still not very known, but I'm working on it now in my new project. And just briefly about the conservation treatment. It included dry cleaning, reattachment of detached plants. You can see here the point adhesion of straps of Japanese tissue, and these are original straps, so this is quite nice, I think. Some of the albums needed resewing, and all of them received custom-made boxes. And what I would like you to remember after this short and stressed presentation is that generally historic herbaria are very unusual and unique objects, and they are at the same time scientific tools. I encourage you to analyze herbaria because there's not much data about it. There's not much research, not many condition reports, so we need data. And because of the heterogeneity of these objects, because of their uniqueness, the techniques you should use to analyze them should be non-invasive or micro-invasive. Just before I end, I would like to thank all the scientists I had the chance to cooperate with. Dr. Tomek Sawoszczuk and Dr. Tomasz Wojewski from Krakow and Professor Piotr Targowski from Toruń. And finally, I thank you for your attention.